Neo-evolutionism is concerned with long-term, directional, evolutionary social change and with the regular patterns of development that may be seen in unrelated, widely separated cultures. Neo-evolutionism discards many ideas of classical social evolutionism, mostly that of social progress. Then neo-evolutionism discards the determinist argument and introduces probability, arguing that accidents and free will have much impact on the progress of social evolution, and asking what if, and considering different possible paths that social evolution may or might have taken, and thus allowing for the fact that various cultures may develop in different ways, some skipping entire stages. Harvey Feinberg states evolution favors those creatures best adapted to their environment. Neo-evolutionism, an enticing, intriguing, and frightening possibility, is the new evolution that is not simply natural, but guided and chosen by us as individuals in the choices that we will make. People today, in some cultures, are making choices about their offsprings. They are choosing to have more males than females. It's not necessarily good for society, but it is what the individual and the family are choosing. Imagine if it were possible for you to choose not simply the sex of your child, but to make the genetic adjustments in your body that would cure or prevent disease. People could make the genetic changes to eliminate diabetes or Alzheimer's or reduce the risk of cancer or eliminate stroke. People would want to make these changes in their genes. If we look ahead, these kinds of changes are going to be increasingly possible. Francis Arnold and Willem Steinman are two scientists who independently developed techniques to encourage the natural process of evolution to work faster, what Francis Arnold calls directed evolution. When people are in a position where they can pass on to the next generation and they can adopt the attributes they want, they will have converted old-style evolution into neo-evolution. It will take a process that normally might require hundreds of thousands of years and compress it down to 1,000 years or maybe even 100 years. Biological 3D printing. Bioprinting works like this. Scientists harvest human cells from biopsies or stem cells. Then they allow them to multiply in a petri dish. The resulting mixture, a sort of biological ink, is fed into a 3D printer which is programmed to arrange different cell types along with other materials into a precise three-dimensional shape. Doctors hope that when placed in the body, these 3D cells will integrate with existing tissues. One goal of bioprinting is the ability to print biological tissues from regenerative medicine. For example, in the future, doctors may repair the damage caused by a heart attack by replacing it with tissues that roll off of a printer. Another advantage is the ability to do bone transplantation without rejection. There are currently projects to replace damaged or missing external body parts. Researchers have fabricated a replacement external ear. At the University of Sheffield, an artificial nose has been produced. Researchers at Wake Forest School of Medicine have been studying the use of 3D printers to print skin cells directly onto burn wounds. A potential benefit to biological 3D printing is that every item printed will be created from a culture of the patient's own cells. The risk of transplant organ rejection should be very low. Potential drawbacks include who will control the ability to produce bioprinted body parts and ensure the quality of the resulting organs. There are also likely to be expensive, which could put them out of the reach of all but the wealthiest patients. The greatest benefit will be availability in the end to organ donor waiting lists. The ethical questions are bound to be of some concern. We have seen in the past. Many major medical breakthroughs have suffered moral resistance, from organ transplants to stem cells, said Tishish of 3D Printing World. Another issue, who will be responsible if something goes wrong? Biological 3D printing should be pursued as a way to save, improve, and potentially extend life for millions of people. In the end, saving lives tends to trump all objections.